So let's write out a little table, and then we'll look at some kind of more general applications of the rules that we've learned. So let's say we've got some number x. This is the column for f of x, f prime of x, g of x, and g prime of x. So what we're going to say is that when x equals 0, these have just been calculated. We don't know where they came from. We just know that a number has been come up with. When x is 0, f of 0 is -1, f prime of 0 is 3, g of 0 is 6, and g prime of 0 is 2. Just, we know those. When x is 1, f of 1 is 1, f prime of 1 is -2, g of 1 is 0, and g prime of 1 is -3. So when x equals 1, the derivative of g, slope of the tangent line, when x equals 1, is equal to -3. We're just kind of told those. So let's look at a problem like this. Let's say that we have some function h of x. And we don't know a whole lot about h of x, but we do know that it's equal to f of x times g of x. We know that about it. And what we want to do is we want to find the derivative of h when x is 0. Now, we don't know what f of x and g of x are. They could be cosine, they could be x squared, they could be something else entirely different. So we can't use our normal rules, like, power rule, bring down the exponent, subtract 1 from the exponent, all that kind of thing. But we do know that when we get the derivative of f, if we put 0 in for it, we have this number. If we put 1 in for it, we have that number. So what we have to do is to try to sort of skip over the steps that we would normally do and just work with what we know. So let's start off by figuring out, in general, we're looking at the derivative. So in general, what would the derivative of h of x be? Well, these are two things multiplied together. So we're going to use our quotient rule, f prime g plus fg prime. But because we don't know what f and g are, I'm just going to write them out in their general form. The derivative of x, whatever that is, times g of x, plus f of x times the derivative of g of x, whatever those functions are. We don't know what they are, but we do know that if we put 0 in for x, we're told what f prime is when x is 0, right here. So in this case, the fact that we don't know exactly what f and g are doesn't end up causing a problem, as long as we're creative about it, because we know what the numbers are and we can get a number at the end. So here, when x is 0, f prime of 0 is 3, g prime of 0 is 6, f of 0 is -1, g prime of 0 is 2. That's 18 minus 2, h prime of 0 is 16. Ta-da! We can find the 0 is 16. Ta-da! We can find the answer even if we don't have those equations. Let's look at another couple examples of that. Let's say we've got an equation j of x, and that's equal to 3 times f of x plus 2, all of that times f of g of x. And we want to find j prime of 1. Here we see two things multiplied together, so we know that we're going to have to use the product rule. So we're going to take the derivative of 3f of x plus 2 times f of g of x, and then we're going to add 3f of x plus 2, and then the derivative of f of g of x. Same kind of stuff we dealt with before, except now we don't know what f and g are. We just kind of have to work with them in general. The derivative of j. Well, I'm looking at this, and this f of x is just something. I don't know exactly what it is, but I do know that this 3 is along for the ride, and I'm going to take the derivative of whatever f of x is. Derivative of 2 is just 0, so nothing else. And then this f of g of x is going to stay along for the ride. Here, same thing, 3 times f of x plus 2. And now I'm going to take the derivative of f of g of x. Here's where we have to remember something about the chain rule. This is the formal statement of the chain rule. It didn't make a whole lot of sense when we went past it the first time. But what we say with this is we say that the derivative of f of g of x is the derivative of the outside function, and then just substitute in the inside function, times the derivative of the inside function. That's the rule that we're going to have to use now. We're going to have to say that whatever is inside here, we're going to take the derivative of the outside function, that f, and then put in whatever's inside, and then we're going to take the derivative of that inside function. We're going to see what this means in terms of the numbers in just a second. So we've got this. We're going to come back up here and look up here and see what we can put in. Let's see, we're doing j prime of 1. So when x is 1, if I look up here, f prime of 1 is negative 2. So I'm just going to put that in. And when I get to this one, it's a little bit different. We've got f of g of x. I'm going to do its inside first, so this f is still along for the ride, but I know that when x is 1, g of 1 is 0. Now, this f of 0, that just means what's f when x is 0, and we'll be able to look that up in the table. Before we get there, though, let's do these other pieces. We've got 3, and then when x is 1, f was also 1, plus 2. Here we've got the same thing that we saw over here. We're going to do the inside piece first. We've got f prime of, and then we said when x is 1, g is 0. And then when x is 1, g prime was negative 3. Let's go back and fill in these last two. So we've got 3 times negative 2 is negative 6. When x was 0, f of x was negative 1. 3 times 1 is 3, plus 2 is 5. F prime of 0 was 3. And there was a negative 3 right there. When we put that all together, j prime of 1 was 6 minus 45, or negative 39. Let's look at a third one. Let's say we know that k of x is 2 times f of x over 3. And we want to find the derivative of k when x is 3. First thing we need to do is find the derivative of k of x. So we know that this 2 is just along for the ride. Here we see a chain rule again. We have an outside function, the f, and the inside function, the x over 3. So I'm just going to put a little box around this to remind me of what's going on. And I know that I'm going to take the derivative of the outside function and leave the inside function the same. And then I'm going to take the derivative of x over 3. One thing that would be helpful to notice for this is that this is the same as 1/3 times x. So when I'm taking the derivative here, the derivative of 1/3 x is just 1/3. Now I'm going to put this 3 in for x and see what happens. Well, I know that 3 over 3 is just 1, so k prime of 3 is 2 times f prime of 1 times 1/3. I know if I go up here when x is 1, f prime of 1 is negative 2. So I've got 2 times negative 2 times 1/3, or negative 4/3.